Hi everyone, I hope you have done your pre-lab calculations for the water hardness experiment. Here we will talk about how to do the calculations for your post-lab reports. Okay, so what you need to do is first you need to go to your virtual labs, okay, and then watch the video, which is the hardness of water for the next week. YouTube link, hardness of water. You click the link and then it will show you how the experiment is being done. Okay, you guys can watch it and then you can start doing the calculations. So you in the same tab where you have the virtual labs, you're gonna go down and then you will see experiment data sheets. So the experiment 8 hardness of water data sheet. So after you watch the virtual video, you need to do the calculations based on the data given in this sheet. Okay, so let's go ahead and download the linked file so I can show you how to do the calculations. Alright, so this is experiment 8. Okay, now the first part that is given here, you don't have to worry about this part. This is being done by the lab techs. It is how you would standardize the EDTA solution, meaning ahead of time you can find out the concentration of EDTA, which is being done for you, and then found the concentration of EDTA solution, which is 0.0113. It's already been done for you, but we will use that volume or the concentration of EDTA solution to do your calculations. Now let's gonna go to the next page, 0.0113. Okay, so the volume concentration 0.0113 molar, that is the EDTA. We need this to do our calculation. That's the molarity. Okay, all right, so they have done 3 titrations for the water which has calcium in it. They have taken 25 milliliter samples, and then you saw in the virtual video how the titration is being done. First you wash the burette with a little bit of EDTA to rinse it, and then you fill it up to 50 milliliter mark. So you have to find out what is the initial burette reading, and then you keep on adding EDTA, and in the flask you have your water solution, pH 10 buffer, and then the Calmer indicator. And you may also have seen that the color change takes place from wine red to deep blue, and then at that time you stop the titration and write down what is the final burette reading. So there are 3 readings like that. Now we're going to use this information to find out the water hardness. Okay, normally the hardness of water is given in units parts per million. Parts per million, in other words, it is same as the number of milligrams in liter. So let's see how we're going to do that with this given data. Okay, so we are given the final burette readings. So how do you find out the volume of EDTA? So it's quite straightforward and easy. What you need to do is you take the difference between these two. 40.9, you subtract initial burette reading. Normally in a burette is a device that you can measure very accurately the volume. It gives us up to 2 decimal places. Even the last one you cannot exactly say what the last number. If it is exactly at 9.9, 14.9, you have to put another 0. I'm going to go ahead and put it over here, 14.90. So this also should be another one, because the burette gives us up to 2 decimal places of accuracy. Okay, like that. Now you subtract these numbers. 14.90 minus 14.20. What's that going to be when you subtract? That would be, what is it? 15? No. What is it? 14.70. That's correct. Hey, you need to do these calculations. I may be doing things wrong. Okay? 14.70. What about the next one? 15. You're going to write it as 15? No. If you do write it as 15, I'm going to take points off. Remember the rules for the subtraction addition? You go by the least number of decimal places. So there are 2 decimal places. Even if you don't have anything, you have to put your 2 zeros. Okay. So the last one, 40. So what we are doing is we take the difference between these two and the difference between these two. Okay. That is good. The last one going to be 14.9. Correct? 14.9? No, you had to put another 0 because there are 2 decimal places. You have to keep that. So those are the volume of EDTA for the 3 separate titrations. What's going to be the average volume EDTA? So the average volume of EDTA for these 3 titrations, they are going to be 14.7 plus 15 plus 14.9. You add all that and then you divide by 3. You will get a number like 14.866. So we're going to round it up. So the average volume is going to be 14.87 milliliters. Okay. 14.87 milliliters is going to be the average volume of EDTA. Okay. Now, so the next one is asking number of moles of EDTA per liter water. How do we find out? Now, let me show you that calculation over here. Number of moles. So, we are given the concentration of EDTA, which is 0.0113, right? And we also know the volume of EDTA, 14.87. So by considering these two, we can find out the number of moles, right? Moles would be molarity times the volume. Okay. Now, the average volume of EDTA per liter of water. So this 14.87 milliliters was used to titrate 25 milliliters of water. But we want to find out if you had 1 liter of calcium solution, which is the volume of the water, what is the volume of EDTA that we're going to be using. So to find that, so you have your 14.87. So 14.87 milliliters is for 25.00 milliliters of calcium. So to find out if it is for 1 liter of calcium ions, so 14.87 milliliters, you divide it by, convert the 25 milliliters to liters, 0.02500 liters. Okay, that is, if you had a 1 liter of solution, what would be the average volume of EDTA? So go ahead and do that calculation. 14.87 divide 0.02500. 594.8. Let's see, 594.8. Average volume of EDTA, 594.8. 594.8 milliliters. You will be needing EDTA if you do it for 1 liter of water. So this amount 14.87 is for 25 milliliters. So you find out if you had a 1 liter, because the ppm is the mass per liter. So we have to convert it to liters. Okay. And then, so that's the average volume of EDTA per liter of water. Now with that amount, we can find out the number of moles of EDTA per liter. For that we need the molarity of EDTA, which is 0.0113. So moles going to be molarity times the volume. So molarity 0.0113 moles per liters times 594.8. 594.8. I convert it to liters. Let's do this calculation. I haven't done this calculation. Let's see, 594.8. Oops, you don't need that decimal right there. I already did that. See, I told you I tend to do mistakes too, so you have to pay attention. All right. Times 0.0113. Okay, cool. Close enough. 0.00672. There are three significant figures in your EDTA concentration, so that's going to be 0.00672 moles EDTA, right? That's the number of moles of EDTA per liter of water, number of moles. We calculated by using the molarity and the volume, right? So this is in liters, okay? And remember the molar ratio of calcium to EDTA 1 to 1. So once you find the number of moles of EDTA, that's going to be the same number of moles of calcium carbonate. So that's going to be 0.00672 moles, okay? And then the next part is number of grams calcium carbonate per liter water. If you know the number of moles, how would you convert it to grams? You have done this. That is by using the molar mass of calcium carbonate. Can you calculate the molar mass of calcium carbonate quickly? Refer to your periodic table. What's the molar mass of calcium? 40. Carbon 12. Oxygen 16 times 3. 48 plus 12, 60 plus 40, about 100. Right? But you need to consider the decimal places also. And when you are taking the molar mass from the periodic table, you have to take up to 4 significant figures. So how do you convert moles to grams? So to find the grams calcium carbonate, you take that 0.00672 moles, you convert it to grams. 1 mole calcium carbonate is the molar mass of calcium carbonate. So 100.09 grams. So moles to moles cancel. You will find the grams. That's going to be, how much is that going to be when you multiply it by 100? 0.6726. Right, 0.6726. But we need only 3 significant figures, 0.673 grams. And then the next part, so that is the number of grams of calcium carbonate per liter water, 0.673 grams. Now the water hardness is parts per million, which is milligrams per liter. Okay, so how do you do how do you convert grams to milligrams? How many milligrams in a gram? 1000. Good. So you take this number and 1 gram you divide it by 1000. See, I did a wrong thing here. I did it wrong. See, that's why I told you have to pay attention. Should be the other way around. So 1 gram. 1 gram is 1000 milligrams. So you multiply this number 0.673 by 1000. That would be the calcium carbonate parts per million. You guys can do that. I'm not going to give you that answer. Okay, so it would be 673 milligrams per liter, which is the hardness of water. So that's how you would do the calculations. Okay. I hope you understood. Let me know if these videos are helpful for you for your pre-lab and the post-lab, so I can keep on making them for you guys. But if you feel like you don't need my help, you can do it all yourself. That's fine too. Okay, but if you do like me to do these, send me an email. Okay, all right then, bye for now.